This is Viterbi Voices.
Coming to you from the University of Southern California, Viterbi School of Engineering.
We're here to give you the inside scoop on research, classes, student life, and so much more.
All of these shared by students, faculty, alumni, and other members of the USC community.
Well, hello, everybody, and welcome back to another episode of Viterbi Voices, the podcast. As usual, I am one of your co-hosts. My name is Paul Ledesma. I'm the Executive Director of Undergraduate Admission here at the USC Viterbi School of Engineering.
And I'm Cameron. I'm a senior studying computer science and business administration at the Viterbi School.
Well, welcome back, Cameron. Your second episode, an old-time pro at this time. Now, for those of you that may have missed it, Maya is not going to be with us for this semester as she is studying abroad in London, but Cameron is stepping in and being a fantastic manager of the podcast, producer of the podcast, organizer of the podcast team, and co-host with me. And as our second episode of the year, Cameron, what are we dealing with here today? I think you brought us your own episode here, right?
Yeah, so this is an episode I produced. This is a conversation between myself and two of my friends, Neha and Emily. Neha is a biomedical engineering major. She's a senior, and Emily is a senior studying electrical and computer engineering. And this episode is all about senior capstones. I feel like for most of the listeners, and especially for myself, when you talk about senior capstone, it's something that you may or may not have heard of, but no one can really explain to you quite what it is you're going to be doing in that class or why it's even important. So I wanted to bring this episode to light just to discuss what's a pretty core, part of getting your engineering degree and actually graduating and understanding what that whole class is about.
Yeah, absolutely. And I think what's important to understand is, and maybe that might even affect how we title the episodes, people understand what we're talking about, but really it's hands-on work through senior capstones, right? So I think that's what's probably the most important element, is that a capstone is a culmination of work that's being done over the course of your years in undergraduate study. And so it's an idea of mixing together the things that you've done to some sort of, and sometimes it's an end product. Sometimes it's a very specific hands-on, like senior project design. Sometimes it's a design capstone culminating in something that you've actually worked on. But capstone, something that you put right on the top, is the idea of capping off an education or an educational arc inside of an engineering curriculum. And I think it's a really good understanding of how hands-on work can culminate. For me, I don't know if anyone else ever feels this way. Maybe it's just a personal thing. But when I was a kid, I was working in grocery stores, and we always had like end cap displays. And so like you had to do like your aisles, and you had to like face your produce or face your groceries. And the end caps, for some reason, I always associate end caps with capstone. I don't know. I also think it's just a me thing, but it's always like, what's at the end? And so that's me. Who knows if that's actually true or not, but capstone, end cap, that's what we're going to deal with. So let's get out of the way and hand it over to you to talk a little bit more about the capstone process and courses that you'll take in your undergraduate studies here.
All right, guys, welcome to the podcast. Thanks so much for listening. My name is Cameron, and I'm here with a couple of special guests here to talk about capstones. How have you ladies both introduce yourself?
Hi, my name is Emily. I am a senior majoring in electrical and computer engineering. I'm also doing my PDP, so I'm still earning my master's in electrical engineering. And this semester, I'm a part of the Embedded Systems Laboratory Capstone class.
Hi, I'm Neha. I am a senior majoring in biomedical engineering. I'm also doing my PDP in medical device and diagnostic engineering. So that's been pretty cool. I took my capstone class a little bit early. So I took it spring semester my junior year, but I took the BME capstone class.
Awesome. And I'm Cameron. I'm a computer science business major, senior, and I recently just took the CS capstone, like CS 401, like design like a broad scale software engineering system this past fall. So it's pretty fresh in my brain. So we're going to hop into it. So this episode, I really just kind of want to talk about like capstones, because I don't know if you guys are like me, but I feel like I really didn't kind of know like what a capstone was going into college. I really didn't even know like what the concept of that was. Like, did you guys kind of feel the same way?
Yeah, for sure. I had no idea really what it entailed. And I feel like it looks different at different schools too.
Yeah, I agree with that. I really just had no idea at all. And I feel like it's even different between the different disciplines. Even within your major, I think you can take like different capstones. So really had no idea.
Yeah, so I guess like for like I'm probably guessing that people, a lot of people listening as well are on the same vibe. So like capstone, senior design, senior projects, like end of year, end of semester, like whatever those are, kind of lumped into the one thing we call a capstone. So you guys kind of like want to take a stab at, I guess, like defining this broad category of what a capstone like is, or could be described as.
Yeah, I guess from my experience, it feels like kind of a good culmination of everything you learn. Like, obviously, you don't use everything you learn, but at least for the BME senior design class, it feels like a good application of the things you might have learned theoretically. You get to like actually create a project that you design instead of something assigned in a class. And it's also cool because it feels like kind of a stepping stone into like working full time where you actually have to apply the things you've learned. So it feels like a good kind of intermediary between the two, at least from my experience.
Kind of hopping off of that, like Neha said, it's very much the culmination of a lot of the skills you learned. If not all of them, I wouldn't say every single class I've taken has an application in my capstone, but you do need to go through like the full documentation process. You need to write a report for it. It's beyond just, I've worked on a lot of just projects for fun, projects with student teams, and it's a little bit different from that because it needs to be somewhat up to industry standard, even though we wouldn't really sell any of these devices or projects that we make.
Yeah, I think that's kind of like a good description of what I did too. Like the CS class, like it's definitely trying to like culminate a lot of this stuff, but like there's some stuff that you don't use. Like if you're a computer science student and you've heard of like algorithms, you probably won't be using algorithms in like your everyday life. You may use like a couple of them occasionally, or you might just like call them from a library. But a lot of the other things that I feel like we kind of use, we definitely like were inside of our capstone. Like we had to know how to like structure things and do a lot of diagrams. And so I don't know, I definitely felt like it was a kind of a departure in some ways of like, this kind of school like mindset of like, oh, we're going to teach you these like very clear steps. I'm just kind of like throwing you into the deep end a little bit, at least, and just saying, hey, do something.
Yeah, I feel like for me, I don't know. I don't know if this is dramatic, but I feel like it was the first time I actually felt like an engineer because I haven't really, like, even in my, like, I haven't done a lot of design things outside of classes. Like, I haven't been on design teams in college or anything like that, or at least ones that use the same kind of like biomedical applications. So that was interesting to me to like actually think of like a device on my own and make it. I'd never used a 3D printer either prior to that class. So like learning how to do things like that was also cool. So I think it was just like, yeah, I didn't use everything I learned. I used some things I learned. I also learned new things through the process. But I feel like that kind of cemented in my head that like, okay, once I leave college, I'm going to be doing things like this.
Yeah, I definitely felt the same way. I was like, I definitely think I'm a real engineer now because like, okay, I took something like someone told me, hey, build this thing. There's no infrastructure. There's no nothing. They said, we just have an idea of what we think we want you to build. And you kind of just built it, which was, I guess, a little different from like my expectation, like what at least I thought it was, because I didn't know anything about it. So I just kind of want to hear like from you guys' perspective, like what did you have any expectations of like what you had thought about the class, what you had heard about the class before going into it? I know Emily, like you're kind of still in the process of like you're actually in the class right now. So like before this semester, like before second semester, senior year, what did you think about Capstone? Like what did you think was going to happen? What are your expectations?
Yeah, I think my perceptions of the class, I had known seniors who had taken it before, was that it would just be like another, I'm in the club makers, so we make a lot of kind of hardware embedded systems projects. So I figured it would just be another one of those. But I would say to an extent, it is like another just embedded systems project. But the difference with Capstone is for us, you really actually have to do it all on your own. Like we're not just using regular off the shelf components that you might find off of like SparkFun or Adafruit, and you can't just use like a generic microcontroller. So typically it'd be like, oh, let me grab my Arduino or even like my ESP 8266, which is like another kind of microcontroller board with the Wi-Fi enabled. I realized I said that as if it would mean anything. But the difference with like the capstone is you actually have to use like the bare bones chip, like just the 80 mega whatever microcontroller chip itself. So any kind of USB port compatibility you have to do on your own, even like adding the clock. So, normally you just like access the clock timer. You have to actually add that on your own, which
Wow.
I think is really unique because it's more like a real industry grade product instead of just, something that you're scrapping together with your own parts for like a student team.
wow, that's actually crazy. You have to build all that, like, kind of manually. Like, so that definitely feels like really real. Yeah.
I
Yeah,
feel like
it's exciting. Yeah, I feel like to build all that. I don't know. I've never actually used just the chip, so I feel like a real engineer now. Like, no, not just, oh, no, I grabbed an Arduino. It's like, oh no, I can make my own Arduino now. I don't need to buy it anymore. So it's cool.
yeah, I feel like mine was okay, maybe not the same, I guess, but like kind of similar, like you said, Emily. Like I feel like for a lot of the labs and hands-on things that I've done in my classes, they've been a lot more structured. So like they'll kind of like obviously you have to think on your own to an extent, but they'll give you steps on how to do things. And then like at the end you'll see the final product, but like you don't really have to work backwards to figure out how to get there. But for senior design, I guess I kind of assumed it would be similar where we'd be like given something to make and then we'd have to make it. And that was the whole thing. But it was interesting to see that it was like they wanted us to come up with our own idea. Like we actually had to like create a device and then we had to figure out how to get there. Like we obviously had TAs and the professor, but like it was interesting to have to do the research on our own and like try to plan out how to get there and realize how little we knew in terms of that whole realm of things. So I think that that was cool for me to like actually break things down and then do it myself and then see the end result.
Yeah, I definitely feel like that is like it's kind of a departure from what we also done, but I feel like that kind of shows like the difference in the type of like senior design or capstone projects because it seems like you were kind of just able to like build like essentially like you just had an idea, you're able to build it, right?
Yeah, essentially.
Yeah, like the CS capstone, it's like actually it's quite different. So like what like the CS process is like when you take the class, and they actually have to requested people for this. Essentially you like, go you sign up for the class and during the first week they send you a document. And so there's about, a couple hundred people in the class because they're like seniors graduating, and they send you a document of like it's like a 31-page document and it's like there's 30 teams, right? And each team can like is like a project. So it's like, oh, this company wants a new website, this company wants a machine learning model, this company wants a new backend, or they want a new API. Like it's just all these different product descriptions. And they say like, oh, this is our company, this is what we do, we're looking for someone who does XYZ. They'll maybe present like, oh, we prefer someone who has experience in this tech stack, or this is the technologies we use. So like some people are like, oh, I want, an iOS app. Then it needs to be written in like native Swift, right? I know how to do that. Not many people else know how to do that. And so if you didn't meet the requirements exactly, you could definitely like learn on the job. But it's definitely very interesting because like we got paired. These are like real world external stakeholders. So like the products you build it's not like sometimes it could just be they just create a project for you, but it's like our project like hopefully like gets put into someone's like actual like website. Like they got it to like use it. And it's actually kind of funny because like I'm a CSBA student and like computer science business. And one of my business classes, one of my business professors actually mentioned, because he was talking about entrepreneurship, he was like, oh, by the way, if you have a project or an idea that you would like to bring to life, you should call up the computer science 401 capstone class and submit your idea for it, because they can more than likely make a app for you for your startup if you really wanted it. So that was actually kind of hilarious that like it's being like the things are real and they're being used on both ends.
Wait, that's crazy. Because for one of my classes, like I'm in the civil engineering, like innovation in global design class, and they were also telling us to submit to the CS capstone class for like, because a lot of us had software projects. Yeah. How much choice, just out of curiosity, do you get? Like, or are you like paired with it, or do you submit your preferences for projects?
So you submit a preference, like we rank, so you get to rank their top five, and like everyone gets their top five. So like you get
Okay.
to, and more importantly, if you know people in the class, like I was able to pick my team. So like teams are typically people of 4 to 5. So I put like, hi, here's me, here's my 4 other teammates. And we want to do, we were project number 31. We want to do project 31 and then 27 and then 4, then, 15. Like those were our orders for our rank. I think we had one more, I don't remember quite. But I just knew we were number 31. And they got back to us like at the end of the second week and they say, hi, here's your project. Here's the email of your stakeholder set of coordination. So I feel like we had a fair amount of control. Like we didn't get to, like, there wasn't like, oh, I want to build this random app, you get to do it. But you could probably find something out of like the 30 something projects to pick that people have that, you can do for fun. I'm guessing like for both of you guys, like, is it kind of the same? Like you get to pick whatever you want, or is it like, how do they structure it?
I guess for the BME, like senior design, it's like there are not many restrictions. I think it's like it has to meet a certain number of like complexity requirements, just so you're not just doing like a super basic project. And they also try to get you to do something that hasn't been done in the class before, so you have reference videos of what people have done. So I guess that makes you have to think a little more out of the box. But it's not, I mean, there's an opportunity to like work on it after senior design and maybe commercialize it or like work with a company for it, if you choose to, but most people kind of keep it within the class. So I feel like it's not, maybe not like industry relevant, but it's just kind of like you create some sort of device that does something. Like ours was like a breathalyzer to detect hyperglycemia. It didn't 100% work, but you know, it was an attempt.
For us, we do have a theme of sustainability. So they have to be smart devices that in some way help for sustainability. And we're given like a list of past projects. So one was a smart beehive, which is an interesting idea. And then there's just like regular things such as like, like irrigation systems. Someone made a shower head that turns on and off at different times to conserve water. And there's just a ton of past projects like that. And similarly, we do have to have a certain level of complexity and other things like that. And also there's a limit on what you can use. So we're not allowed to use something like I don't know exactly how you call it, but something with like a RPI level of complexity of the chip. Like it needs to be able to be done on a similar processor to like the bare bones, like at Mega, which is just like doesn't have that much memory. So you can't do things like, run a super complicated computer vision model. Cause I know we kind of want to do that on our team. And our professor just said, like, that's not allowed. Like it needs to be something that like the consumer can just use pretty easily. And that could be like more off the shelf.
I see. So kind of with that, you guys kind of like spoiled, like, or not spoiled, but you guys are transitioning perfectly into it. So Emily, like, have you actually picked your project or know what you're going to be working on? Okay, so I just want to make sure because I want to go around and kind of see like what do you guys like actually like what was the capstone project? Since like we're talking about this, we're gonna experience like what was the project?
Yeah, so I've picked my project. We're still making it. Although I did just get my first component, which was a $2 cabinet that I bought from Facebook Marketplace to put our bins in because we're making a smart trash can to sort your compost, recycling, and trash. So nothing like too crazy. If we complete that, we also want to add a feature with the compost bin to allow you to have better conditions, not for composting, but for preserving compost, because a big issue with why people don't compost is that obviously they don't have their own compost bin in their apartment complex or their home. Like that takes a lot. Like you have to have a lot of space. It's really stinky. So one thing we wanted to do is in that compost bin, since it's for personal use, we're not allowed to do something for like a company to use or a factory. It has to be for an individual consumer, is making a condition so that it's like somewhat like freezing in the compost area, since that's normally when people want to compost, they just stick it in the freezer and wait until they have the opportunity to take it to a proper compost, I guess, resource to dump it into. So having the compost bin itself maintain ideal preservation conditions. But we're not sure if we'll do that part of it yet, since we're still kind of just doing it. But it'll just be a smart sorting trash can.
That's so cool. I would use that. Yeah, I'll be your
Oh,
customer,
thanks.
Emily. I guess for mine, I kind of mentioned it, but we basically like I don't know, someone on my team was really interested in breathalyzers. So we were trying to figure out like a clinical application for breathalyzers. Um, and so we found like some research, it's still like being done. So we weren't fully sure about it, but basically tying like acetone levels in the breath to hyperglycemia, which is like an indicator of diabetes. So it was like, that was kind of the goal of our device was, it was like a quick at-home monitoring thing for people with diabetes to detect when their blood sugar levels were high. The research was a little shaky because it wasn't very readily available, but that was basically what we made. So it was cool to like use like electronic components for at least for my first time, and also create the casing for the device and 3D print it.
Wow, that's very cool. Yeah, I would have never guessed a breathalyzer could actually like do something like that.
it was very basic. Like it lit up red if the like levels were too high, but it didn't tell you the levels because we didn't get that far. But it was like a red green kind of indicator. So like I think its main use is like if your levels are really high and you need to go to the hospital, like it'll tell you. But other than that, it's like it needs to be developed further.
Yeah, that's still really cool. And they have one question for that. Do they ask you to build it for like clinical use, or 'cause you said that that's at home, but also kind of could be used clinically, or like what was the prompt there? Was it like for people to use at home, for it just generally for the capstone, or did it have to be for clinics?
Yeah, so the capstone is like, at least for my year, and I think that's how it is for senior design. It's like it's pretty open-ended. So I guess like at first we were thinking of it for clinical use, which is why I said that, but then by the end of it, we realized like given its lack of specificity, it's probably best for at-home use and kind of just like a warning sign. Like if you're feeling dizzy and you use this and it lights up red, like you should probably eat something and then go to the hospital.
Yeah, it's still pretty cool to have like consumer tech because I feel like some stuff feels like very theoretical. But like both the projects, like, oh, like this is something like I could buy and then use. And I feel like even still, like if it's a just like a red light, like that's probably like was the most basic thing of like an early breathalyzer didn't give you like a 0.08 reading or something. It was just like a red, the breathalyzer said this is red, red means bad. Like, so like it's probably like all
Yeah,
the
it's
same thing
true.
very much. Like you're pioneering an early technology, like, think about it like that.
Thank you. I feel very hyped up now. Thank you.
Yes, for real engineers. For the CS capstone, like ours was a little bit different. So basically, we consulted for this company. Essentially, the company was a consulting firm. And essentially, the goal for the company was to try to recommend AI products. So like literally artificial intelligence, like persuasive interface was the name of the company. It was like iPi3. Interesting name. Basically, the goal was to just, analyze customers, like, assess and technology needs, assess whether or not, where they were, and then be able to recommend them artificial intelligence. And actually, they used that was to use like machine learning models on like customer provided data. So like essentially we built like a front end web interface where like customers would, take a quick survey and like a front end, like building React, they would submit like, piles of like data. So whether that's like Excel sheets or like RSV files, some other like files of like customer data from their own telemetry documents. And then we would go have a backend that actually process that data and find like trends of like, oh, we noticed that there are outages when you do X thing, right, on your website. So like it'll be like, oh, we noticed there's outages at like a very particular peak time for a resale company or something like that. We didn't really have like a good customer example of like this is what it was, but we just found like we were able to find trends in the data and then be able to recommend like, okay, here's the pattern we found, and then recommend a product based on the company. So kind of like a more specific like product recommending service for like this one particular company. I guess kind of similar to how like the Amazon engines work, where like they take in like your previous data and figure like, oh, what you might want to buy in the future. So it was kind of interesting because it required like a good bit of like web development. Obviously, like you need an interface and a file upload and everything. There needs to be a server, and then on that server there needs to be like machine learning is like a good buzzword, but like basically like a regression model to like find trends and figure it out. So a good bit of data science as well. So I know machine learning AI is like buzzword and like chat GPT, but like it wasn't like that crazy. It was just like minimal machine learning regression models, and it worked out.
Yeah, I love throwing machine learning into things, and it's just like logistic regression. I just add that to all my projects to make them look flashy.
No, that's actually like a big issue in general. Like people are like, oh, like all these random companies and these like tech entrepreneurs, like, oh, we're going to use, machine learning is at the core of our product. And I'm like, are you sure it's just not an engineer clicking like regress on like a set of data, like a regression like I did in like AP stats in high school?
Yeah.
The worst part is like I'm the person who falls for that because I still don't really know what machine learning is. So when people say it, I'm like, wow, so smart, incredible. But like, I don't know.
Yeah, and it's so funny when you take the AI class because like literally like in the intro to AI class, like all it is to teach you a bunch of like search and like regression and like training models, and it's like that's really the fun of AI. That's like a really horrible simplification of it, but like that's all it is. And I'm like, yeah, like we're definitely getting scammed here a little bit because like I guess that's a good thing about being an engineer because someone uses all these buzzwords and then you're like, nah, bro, like I know what you're talking about and I know like it's not that serious. someone the other day asked me, they were like, oh, talking about Chat GPT, and this like random tech bro pulls up and he's like, dude, like, do you know what type of machine learning model they're using? Are they using Stable Diffusion? And I'm like, I didn't take the advanced machine learning class. I just took the intro to AI. Like, I don't know that much, but like people know about this stuff. So it's kind of funny.
I feel like that's what I guess that's when you realize like you're kind of a real engineer, is like when you understand the buzzwords and then you understand that they're overhyped. Like I'm realizing that right now, like because I'm doing a co-op at like a medical device company. So I'm working with a lot of engineers and I'm realizing like when I actually understand what the words mean, I understand that like a lot of them are just used for the sake of being used. So I guess that was a cool thing that came out of the capstone class too, was like learning a lot of like industry relevant terms that like I would hear a lot that would intimidate me, but now that I understand them, I'm like, oh, they're just like standard words that people say to make things sound cooler.
Wait, Neha, quick question. Have you heard of nano drugs? So you're a BME.
I have heard of them. I don't know much about them, but I know they exist.
I was at this like this startup whatever pitch competition, and this one person came up and was talking about how they're making like this like nano drug mixing thing. And I just thought to myself, I know something's fishy about this, and Neha would know. She's BME. She
She
knows.
does not know, but I like I feel like nano stuff, because there's a lot of like nanomedicine and like nanotechnology related developments in BME, and I feel like I just buy all of it because I don't actually understand any of it. So I'm like, wow, that's so cool. That is like the new frontier in science. But yeah, it's kind of, I don't know, it's weird to think about.
Because I think of nanotech, I think of like, wasn't it like in Big Hero 6, like one of the villains had like the nanotech suit or something? He like was able to make it into any shape. And I'm like, yo, I want to do that.
Yeah.
Like
And that
that's what I
reminds
think
me.
of. I think of like something supremely sci-fi where it's like, yeah, I help this like this like backpack of like nanobots, and then I can just like control them like with some thoughts or something, or like some type of interface, and they just like make this like random shape of like a step stool or like a shield or something, like some like random sci-fi movie. That's what I think when I think of nanotech, or like the robots in your body, like you know what I'm talking about? Like am I
Yeah, yeah.
Yeah.
like please don't, I'm
No,
not
That's what
that's
I
what I
think
think
of.
about. Like with nano drugs, I feel like that's what I think about. Is like these tiny little things in your body just like fixing things, which is like very non-scientific, but like that's what you see in the movies. So it's their fault.
It's the movie's fault. Now for another class I'm taking, it's what is it? Software design for EEs. So you have to do some software stuff like with an EE application. I think our project title is like superconducting quantum something something. And I just feel so like Marvel, you know. I really feel like I'm part of the MCU with my it's really actually like it's cool, but it's not cool. Like I'm making like a circuit verification. It's very, very boring. But it sounds so cool. Like I feel like I'm about to be one of those, Tony Stark whatever they call, but in reality, it's not.
Engineers are good at like making things sound really cool. Like I mean, I know this is like not the stereotype, but I feel like engineers are good with words in that way. You know what I mean?
Yeah, like as long as you're talking to someone who doesn't have a background, you can just like use all these fancy buzzwords. But then the issue is when you're like trying to flex, and like of course it's like typically they use fancy buzzwords when you're trying to talk to random people. But the one time, oh, I'm definitely gonna flex on this person, and then they're like, oh, actually, I'm like a researcher at a quantum computer laboratory. It's like, what are you talking about? And it's like the one time you thought you were gonna flex, it's like I mean an expert in the field, and I'm like, I'm screwed. So, but yeah, that is great. Like engineers are definitely good at hyping up their work. I never thought of that. So I guess like I'm curious, like what do you kind of feel like were some of the skills that you learned from like your capstone? And Emily, I guess like what are you hoping to like get out of your capstone experience?
For me, a lot of it was like design thinking. Like my professor put a lot of emphasis on the design process, which I'd never really thought about for like medical devices. And like we learned a little bit about like industry standards and regulations that are actually like relevant in the job I'm working in right now. Um, but I think like in terms of technical skills, it was cool. Like 3D printing, like I mentioned, I'd never really done it before. So like realizing that you have to make certain allowances when you're creating something physically, like things like that I'd never thought of were interesting. I got better at modeling, and then also just like working with sensors and programming in Arduino, stuff like that I'd never done before. I did for that project. So I think that was cool. And I think the last thing was like taking established research and like, I guess, biological concepts and stuff and applying that to a device was something I'd never done. So I think like, yeah, like actually applying things that are out there in the literature was cool because like I'd just never done that before.
Yeah, I think for me, what I hope to get out of it is really learning how to make something that's somewhat industrially standard, not just like the industry standard, because I've made a lot of projects and I do a lot of hackathons and stuff. I'm hacking together things with an art pie and various sensors that you can get off the shelf or just order online in bulk. But I've never actually made something with like just a process, like a microprocessor, a microcontroller, and actually had to add things myself. But later down the line, I want to be able to make my own products eventually to some extent. I don't know if I actually will, but having that skill is just another step in that direction where I could think of, hey, if I actually wanted to make something commercially viable, how do I order things in bulk that are, actually manufacturable as opposed to you can't put like a full RPi into something you're actually trying to sell, or you can't put like an actual Arduino into something you're trying to sell. Like you need to be able to just think about what you need. You even have to have like considerations. It seems like for memory, do you need to add extra memory? Like you have to do that by yourself, which is just not something I've ever done before. It's something I think is actually really practically useful for industry grade products.
Oh, very cool. By the way, is R Pi like the EE slang for Raspberry Pi?
Yes, I'm so sorry. I should the Raspberry Pi.
No,
I
because
was
I'm
wondering
like,
that too.
because there's like so many abbreviations, like, oh yeah, like using an R Pi. And I'm like, am I like, I don't know much about like circuits, but I've heard of a Raspberry Pi before. And I'm like, R Pi, Raspberry Pi is kind of a computer. Like,
Yeah, yeah, it is. Oh, that reminds me when I first heard of what a Raspberry Pi was. I remember I went to this like info session for like one of those, making clubs, and they're talking about Raspberry Pis. And I thought they were talking about real pie because there's like a bunch of words that I didn't understand. And that was the one thing I understood, but I actually did not understand at all. I was like, oh, that sounds familiar. But yeah, it's like one of the essentially like a mini computer that you can it has accessible general purpose input output pins, so you can actually interface it with other electronics. For the listeners at home who may or may not know what that is.
very cool. I just had to check my knowledge. For me, I guess like what I got out of it, I think that in general, like working, mine's actually very different. It's really much like working with a stakeholder and like going through the process of like reviewing and iterating code. Cause like I think that like, especially for most people who like do computer science, like I didn't really grow up doing computer science because I like just switched to CS like since I like started college. But I was told, oh, do some side projects. And I made some side projects. Like I learned like I made like a little app here, like then tried to make like a little website startup, just like or just like start up like my own websites, like oh, it's not like an actual company or anything. But like just trying to do it. And like it was fine to get like the first version out, which was really cool. But it's because I just kind of like, figured it out as I went and kind of made changes on the fly. But like the capstone class really kind of forced like me and my group as well to like we really had to like think carefully about like how we were going to design it beforehand. Because I feel like a lot of times in CS, you just kind of like get started coding, even though like they tell you to never do that. Like we just kind of always do, oh, we're just going to code and figure it out as we go along. Whereas this was like, no, we need to learn, like we need to figure out what is our architecture diagram looking like? What is our user, diagrams, user stories going to look like? What is our database schema? Do we need an API? With API isn't a scare where it's just a communication between the back end. Are we writing them in C#? Are we using servlets? Like, all these like small details, which could have been like figured out much later. We could have just like started writing stuff and then figured it out as we went along. But we literally like couldn't code until we had like a plan in action because like that wasn't the point. Of the class because like we could have probably put this up like pretty quickly, but actually going through and like making decisions and figuring out why this wasn't the right decision kind of definitely felt like much more like industry style because in the industry they wouldn't just tell you like, oh, start coding this feature. There's like a design review process, and so in many ways I feel like it definitely really kind of helped like get that more like industry feel, at least for me. I'm not sure like if you guys like compared to internships, like if Capstone kind of mirrored the industry, because I know for me, like they definitely did. I felt like, oh wow, like I've done a design review before. I've had to like, present my work, stuff like that. So it kind of felt pretty, somewhat closer, trying to mirror industry.
I would definitely agree. I think, especially for me, like now I'm working in like a research and development role, where the design process is like a large part of it. So I think the kind of getting the framework from my senior design class made me realize like how to approach something that's industry relevant. Like obviously the thing I worked on for senior design didn't have like clinical applications or anything, but when you go into industry, that's not the case. So I think that part of it was definitely helpful. Also just like getting familiar with like documentation practices, stuff like that, industry standards, regulations, obviously like medical device regulation, or it's like a heavily regulated industry because it goes into people. So I think just having an intro to that from that class was helpful insight when working in industry because I could actually like see firsthand the applications of what I learned and be able to have some sort of framework when people talk to like somewhat know the acronyms that were being thrown around.
Yeah, from what I can tell, the capstone seems really industry relevant because you do have to write all of documentation for everything you make. You have the design reviews. Most of it is that design process, which is very similar to industry. Even Cameron, what you were talking about, having to make all those diagrams, like my last internship had a big software component, and my mentors and my managers were always asking me for, my UML diagrams and make sure you have
Oh my
this
goodness.
and this and your flows and all of that stuff. So there's a big difference, I think, between like hacking something together, even if it technically works, and actually having it be presentable and have proper documentation and proper flow. And there's definitely a value in that, as much as I'd love to just, hack something together and call it a day, but it makes your work, I guess, last longer because people know what's going on and they can change it and debug. And it's a very valuable process, I think.
Yeah, to know that, like, especially the documentation part, like, if anybody knows anybody, there's not enough documentation in the world. Like, I literally dealt with that my last internship that, like, I could not figure out why anything worked. I literally waited, like, for over a week to try to call the right person to figure out something works. So, like, learning how to document is, like, something that's, like, critically important, like, especially in my work. Because I'm like, man, if you had just spent, like, a day, just, like, one day, like, writing documentation, this probably would have saved me, like, a week trying to figure it out. To the point we literally spent like a week because like our stakeholders like very stern about documentation. She's like, I want the documentation to be such that if someone could just read the documentation, I want them to be able to build a very similar project to what you did if they never saw what you built. They're probably not that crazy, like, but she was had a PhD in like computer science. She was like a stickler for this. But like writing the docs was like really good, like world experience, like real world experience, and I kind of liked it. Something else I kind of want to ask, like, in our capstone, like we had to like do like a final presentation. I'm assuming it's similar for you guys. And so I guess like, how did you feel doing it, or like how confident you feel in presenting your work? Because I think that's kind of like the last hurdle for engineers. It's like, I built this thing. Can I tell someone who really doesn't know about my project what I built and what I did?
Yeah, I think so. We had like a kind of like midterm, I guess, presentation, which was like in the middle of our design. It was like the end of our design phase where we were basically pitching the concept. And then we had a final presentation where we actually showed our finished device and we talked through like not our planned design process, but like what actually happened when we were executing everything. And yeah, I think it was a really good experience because I feel like this is something a lot of engineers fall into, which is like, like you believe in your product or project, but like when the time comes that you have to explain it to someone else, you're not very confident about it because for whatever reason. So I think that was a good thing for me and for my team for us to like focus on being very confident in our delivery because at the end of the day, we were supposed to like pitch it to the class. So I think having that element of it where it's like a persuasion kind of thing made us structure our presentation differently. And it was also just nice to like think through like how lost we were and how many times we pivoted in the design process and then like break down the steps of our actual design. Because I think that like cemented that we knew what we were doing and like we were able to look through our failures and the things that we did incorrectly and talk about what we learned kind of like was a good wrap up. And we got good feedback. So I think that made me feel like an actual engineer because I feel like that process is similar in industry.
Yeah, I definitely say like that kind of feels like the common thread throughout like capstone senior designs. Like it mirrors industry because like that final review and presentation like is like pretty critical. Like I can know like I'm guessing like Emily because we worked at the same company, and so like that final presentation like there's a lot on that. There's a lot of focus on it, and you could have such an amazing summer, an amazing like project, an amazing like work But, like I said, if you can't really communicate it, I feel like, I don't know, like people really don't, they won't really understand like, oh, wow, this is super important. This is a really intelligent person. They're deserving to like continue to produce work if, you build it. But there's and it works great, but it's like, okay, well, what does it do? Because most times, like sometimes your boss or like your CVP, your like vice president or like, your whatever your lead, like may not know like how exactly it works.
Yeah. And I think one thing that also reminds me of is like, I guess documentation again, because I thought it was really tedious when I was doing it because we had to do a lot of write-ups for our senior design project. But then I realized like at the end of it that writing down all of that as a reference like helped me at the end when I'd already moved past all those things. My memory's not great. I would not have remembered what I'd done if I hadn't written it down. And then in my internship, I made that mistake where I didn't like write down my own work. I kind of just went through the summer. And when it came time for my final presentation, I was like, oh my God, I know I've done a lot this summer, but like I don't remember any of it enough to articulate it well. So I think that really like hit it home for me that documentation is important and like keeping track of everything so you can explain it well, like you said, to someone who doesn't have context on it.
I haven't had my design review yet, but if it's anything like the internship ones, as Cameron and Neha said, it's really important to be able to actually convey why the work you did matters to the company, to any stakeholders. Otherwise, you could do a great job. They simply won't care because they won't feel like it's applicable. And like Neha was saying, having, those graphs, those diagrams, the notes throughout the summer, I think something that really helped me with my last internship was that my mentor was a stickler for that stuff. And so was my manager. So I had to have really detailed, design plans and charts and everything. So then when it came time for my final presentation, all I really had to do was modify some stuff, grab some stuff, and I could really form a cohesive story fairly easily that was pretty presentable to the CVP and leadership, which ended up really playing well in my favor. And I think it would have been a lot more stressful for me had I not been keeping that consistent documentation because my memory is also not great. I forget about the things, especially after you've been working on some project that's giant and it's been months, you're going to forget about those first steps. So it's definitely really useful.
Yeah, it kind of keeps you on track. And like for the CS version, like we had like a couple check-ins. So we had like 7 total deliverables, which are really just documents like basically telling like what we did. And like they were roughly basically every 2 weeks, which is kind of funny because like at work, like all the time, like in internships, like we have Scrum, like Scrum or like stand up pretty much. Like Scrum is like twice a week, stand up for us was once a week. But we had to stand up with our manager once a week. And literally like this was times to talk about, okay, what have you done this week? How's it going? How long did it take you? How long were we working on it? We had like a limit of like, we weren't supposed to work more than like 2 hours per week on this because it was like the project wasn't that scaled, but like the goal was to spread out the work. Or we had 3 or 4 assignments, and each of those assignments shouldn't have taken more than like 2 hours per week. So like if you were working for like more than 8 hours, like on one assignment, you probably like structured your work wrong. And it was so funny because like you need to like, that's a work thing. Like if you go to work, you have like your weekly meeting, like, oh, tell us what you've been working on for the week. That's basically what the capstone did because you can't just say, oh, I'm taking a week off, I didn't do anything. That's not really acceptable in the capstone era, and that's like really not acceptable work. You need to like always at least be making progress towards something. So I thought that was kind of funny when they're like, oh yeah, I literally did this like a couple of weeks ago when I was having to stand up with my manager and like stand up with my manager's manager, and now we're like here talking about this with our TA who's like kind of one of our managers. So I thought that was really cool too, as far as the experience. But yeah, like any final thoughts about capstones and senior design before we wrap up?
I guess this is like a unique thing, but like I mentioned, I took it early. Like I took it spring my junior year. And I would definitely say that taking it sometime your senior year would be better because I feel like now that I've taken like almost all of the classes I need for my undergrad, I feel like a lot of them I can see how they would have been relevant to my senior design project. So I guess that's the only thing is like it is like a really good culmination of everything. So I feel like taking it like Cameron, you said you took it in the fall, right? Like I feel like taking it fall or spring senior year is probably the best time to do it.
Yeah, like Neha said, it feels like wrapping a nice little bow on my undergraduate electrical engineering education. Like I'm still taking classes for my graduate EE, but it does feel just like a really nice cohesive way to wrap everything up. You're still learning a lot, but also there with all there's other electrical engineers. It's fun that people take different classes, or just even in the class, like my professor had us all introduce ourselves, even though we've been in the major for 4 years. But it was cool to see what everyone's up to and how things have changed from, we haven't been in a class all together, I think, since like freshman year, first semester. So people have really grown a lot and changed. So it's a fun way to just wrap everything up.
Yeah, I can agree. I think like it's definitely kind of a good, culmination of everything. And like it was cool as well. I would definitely like echo Neha's point because like with the CS like requirement, like you can take it early since like the last, like technically like depending on your schedule, your last requirement to complete it can really be done like second semester sophomore year, like based on like the prerequisite for it. So like a lot of your 300, you could take this class as a junior. And then so many of your 300 and 400 level elective courses can be taken after this. And so I think like it might benefit you to kind of wait a minute to take the classes like one of the last ones, just because like if you're really interested in AI, right, you could actually take the AI and take the machine learning class and take AI for sustainability as some of your electives. And then by the time you come to your capstone class, you can actually really power through the AI class, like their or AI project they have you because, oh, wow, I did this. Or I don't know, like if you want to work on something that's like very hard, like we don't really have hardware projects, but if there was a project that was working with a hardware company, you might be able to understand it a little more. Or like if you wanted to really build some like low level system for a company, you could kind of like take a low level spin on something if you take like a lower level computing class. So I definitely agree. Like you can take it later, but as Emily said, a nice little bowl on top certainly doesn't hurt to kind of put it together. But yeah, thank you guys for just kind of engaging me for a little bit, talking about capsules. I feel like it's kind of something a little mystical, but it was really cool to hear your experiences. You got to talk about mine as well. So thank you guys so much. All right, and welcome back. Thanks for listening to the Main Body episode. Really great conversation. Really glad to get some insights from Emily and Neha and really just, get a chance to kind of talk about all of our unique different processes that are somewhat same, but also pretty different depending on the major.
How many capstones have you had or will have had by the time you're done?
So I've had just one. That's because I elected to have just one. In a computer science department, you can actually take the capstone twice since you get matched. As I discussed in the main body, you get matched with external project stakeholders. So you can take the capstone twice, once for your capstone credit and once as an elective since it's a different project.
Right. And there's different capstones depending on what you want to do, how you want to do it. So it's not like, to be clear for everybody, it's not like you have the one capstone for your major.
Mm-hmm. Yeah, you can take different ones. Right. I know for CS there should be an alternative. I think it's like, starting the high tech startup is one of them. It's like course code like CS 404 instead of 401. That's always an option. And there's just even like other classes you can like go through. You really just work with your advisor. They'll tell you, here are all the options available. I just went the standard route, but for all of the majors, you can do some other cumulative projects. And some capstones are even like full years. Like within a major, you can do a full year capstone for, different types of engineering if you really want to.
Yeah, some are 2-semester projects where you started in one, you move on to the other. And again, there's so much stuff out there. And I think that's what's important to understand is that this conversation is a small snippet, a sliver of individual students' experiences. And there's so many other things out there. So when you take a look at it and you look at even your curriculum, you'll see that capstones are part of your curriculum. Sometimes it's a specific class you need to take, or as Cameron mentioned, it's a capstone. So you have these options to choose from in the types of capstone work that you need to do. And some people will ask us in the admission process, like, is there a thesis? Is there a senior project? Yes, no, maybe across the board, across the way, because the curriculum is so flexible. Some people would consider, like I said, some are like, for example, in mechanical engineering, there's senior project design. It's definitely a capstone, but people probably call that senior project design. They don't call it a capstone. And so just keep in mind that there's different names for different things, but all of these are culmination end projects as we move forward. So lots of stuff happening, lots of hands-on work. And this is, again, the culmination of hands-on work throughout a 4-year degree. And I think that's what's important as well, is that getting your hands dirty, doing stuff, making things, breaking things, building things. That's what this is all about. And you'll be doing it throughout your time here. Well, with that, Cameron, thank you so much for bringing this episode. And thank you out there for listening. This would wrap up this particular episode. And we will see you next week with another one of Viterbi Voices.